Alright, so today we're going to be looking at end behaviors of polynomial functions. Alright, so our main focus is if we were to draw this function out on a piece of paper, what would my end behaviors tend to look at? Alright, so the first thing we're going to do when we do these, alright, we're given it. First thing we want to do is we want to get it into standard form. Alright, so we're going to get it into standard form. Alright, so remember standard form, we want to put our polynomial from largest degree. Alright, so here our largest degree is 7. Alright, and we want to go to our smallest degree, which is 2. So when I put in a standard form, alright, negative 6x squared to the 7th goes first, alright, then positive 9x to the 5th, alright, and last 4x squared. Alright, from there I need to look at the degree of my polynomial and then the leading coefficient. So here's the degree the polynomial, and here's the leading term. All right, and what that's going to do is it's going to tell me the end behaviors. What I mean by end behaviors is if I were to draw this out, it would look something like this. And I want to determine what are my end behaviors. Am I going up or am I going down? All right, so to do that, we're actually going to use this chart, which you also can find in your book. So this chart tells me that if I have a positive leading term, all right, if I have a negative leading term, I have these two options. If I have an odd degree, you have these two options. Even degree, you have these two options. So if my leading term is positive and I have an odd degree, I'm going to go down left and up right. All right, if I have a positive leading term and an even degree, I'm going to go up left, up right. If I have a negative leading term and an odd degree, I go down right, up left. If I have a negative leading term and an even degree, I'm going to go down left and down right. All right, so now if we go back and look at our problem, all right. So if I look here, I look at my degree, I look at my leading term. So I know that my degree, right? So my degree is odd, and my leading term is negative. All right, so if I go back to my chart and I look at negative leading term, odd degree, I know that my end behavior is going to be down right and up left. All right, so here I can write end behaviors. All right, so we said we're going to go down right and up left. All right. All right. So again, what that kind of looks like is, so if I were to draw, it looks something like this, where on the right side it goes down, on the left side it goes up. Again, I don't know what it looks like. It could loop more than once, twice. If you wanted to, you could go on Desmos and graph it. All right. All I know though is the end behaviors is on the right it's going down, on the left it's going up. All right, so I'm going to write that last step I did. All right, so use leading term and degree to determine end behaviors. All right, so let's look at another example. All right, so example 2. All right, so if we look at example 2, again, it's not in standard form, so we want to get it in standard form. So I look here, I say that 8's my largest one, so I'm going to put 7x to the 8th. All right, then I look x to the 3rd is my next one. Negative 3x squared is my next one. All right, plus 3. So again, this is my largest one. My largest exponent is my degree. All right, this is my leading term. And so again, now I determine, all right, look at my degree. I see my degree is even, right? It's 8. My leading term is a positive 7. So I have a positive leading term and an even degree. So if I come back over to my chart, I look at positive leading term. All right, I look at even degree. I see that it's up left and up right. So I can write in behaviors, right, up left and up right. And so again, if I don't actually know what's going on in the middle, all right, but what I do know is on the right it's going up and on the left it's going up. It could do all sorts of loops, right? It could jump around and do all sorts of things in the middle. We don't know. All we know is that the end behaviors are up left and up right. All right, let's do one more. Last one. All right, so this time I'm going to do it slightly different. So if I'm looking at it, I can actually kind of, if we get good at it, we can actually kind of skip that, put it in a standard form position. All right, so what I mean by that is if I actually just find my largest degree, right. So if I just find my largest degree, which if you look here it's 5, right? So right here, that's my largest degree. So here, so without putting in standard form, that's my degree. But I still have to realize that this 5 right here, that's now my leading term, right? It's not leading because we didn't put it in standard position. But in this case, it's my leading term. All right, so now if I do it without putting in standard form, I can look at it and say, okay, my degree is 5. All right, so I know I have an odd degree. My leading term is plus 5. So I determine that it is positive. All right, so let's go back to our table. All right, so we look back at our table. An odd degree with a positive leading term. All right, should be left or down left and up right. All right, so again, I drew little pictures here to kind of visually see it. So we'll down left, up right. So I come in here, I can say in behaviors. All right, so I know it's down left and up right. All right, so in a general way, that is how you find the end behaviors if you're given a polynomial. All right, so we're going to look at one more thing here. The other thing you might see is I might give you a graph. I might give you a graph. It doesn't look pretty. All right. And again, it doesn't matter really how many loops there are. All we're worried about is the end behavior. So if I look here, I see that it's down left and up right. So something I might ask you, zoom out here, is if given a graph, can I determine if odd or even degree and if positive or negative leading term? So if I look here, it's down left, up right. If I go back, that's not it. If I go back to my table, right, and I want to look for the one that's down left, up right. So I look at my chart, I see this right here. This is my down left, up right. So I can I can go to my ends and say, okay, I know that has to be a positive leading term and an odd degree. So I can come back here and say, this has a positive leading term. And we know that it's an odd degree. All right, so that's all I can really say about that one. I don't know what the degree is. We can't determine that. We don't know what the leading term is. We can't determine that. So all we're really worried about is finding if it has a positive leading term and an odd degree. Finding if it's positive or negative leading term or an odd or even degree. All right, so let's look at one more. All right, so if I have this on a table, so right here, all right, so right here is my graph. All right, so if we look, I see it's down left, it's down right, right, down, down, and you might also recognize after you do a few of these that all the even ones go either both down or both up. All right, all the odd ones like this one, right, either switch down, up, or up, down. All right, so the odd ones always go opposite directions. The even ones always go the same directions. You might have caught on to that. All right. So again, one last time, I look at my sheet. All right, I want to find the one that's up left, up right, or sorry, down left, down right, because they're both down. And I look up, I see that's a negative leading term and an even degree match up to get right down left, down right. So I know that this one has to have an even degree, or sorry, a negative leading term because it's down. Right, and an even degree. Okay, so there you go. That's how you can both go backwards and find if it's a positive leading term or negative leading term, an odd degree, even degree, as well as if I give you a polynomial, can you determine its behaviors.